Hello, everyone. Thank you so much for joining me today. My name is Stephen Camilletti, and I'm accompanied with my partner, Daniel Lumley, to talk to you about our ME416 Project 3 Finite Element Analysis of Heat Transfer in Fins.
The objective of this project was to study the rate of heat transfer and temperature of a rectangular fin geometry at infinite length. We had to observe our fin using copper, aluminum, and stainless steel. Lastly, we had to compare the theoretical and analytical results using equations from the book in ANSYS.
Some of the parameters needed are the thermal conductivity coefficient of each material. Copper is 401 watts per meter Kelvin, aluminum is 205, and stainless steel is 16. The temperature of the base is 150 degrees Celsius, and the ambient air temperature is 20 degrees Celsius with a convection coefficient of 60 watts per meter squared Kelvin.
One of our first parameters was to calculate infinite length for each material, and the equation is shown below. Using a width of 10 centimeters and a height of 5 centimeters, the determined infinite length to be used for each material is 10 centimeters.
On the left, you can see the temperature distribution from ANSYS Workbench of the copper fin. It has a minimum temperature of 142.12 degrees C at the end, and on the right you can see the heat flux distribution.
On the left of this slide, you can see the temperature distribution from ANSYS Workbench of the aluminum fin. It has a minimum temperature of 137.18 degrees Celsius at the end, and on the right, you can see the heat flux distribution.
Lastly, on this slide you can see the stainless steel fin mesh. On the left there's a temperature distribution of 56.895 degrees Celsius, and on the right is the heat flux distribution.
Using the equation shown, we calculated the theoretical temperatures for each material. Copper has a minimum temperature of 116.34 degrees C, aluminum has a minimum temperature of 105.5, and stainless steel has a minimum temperature of 49. From here we calculated percent error between theoretical and experimental results of copper to be 22.16%, aluminum to be 30.03%, and stainless steel to be 16.11%.
Using the equation shown, we calculated a heat transfer rate of copper to be 780.97 watts, aluminum to be 558.4 watts, and stainless steel to be 156 watts.
In conclusion, copper has the highest end temperature and highest heat flux, while stainless steel has the lowest end temperature and heat flux.
Thanks so much. Any questions?